So if you can still remember our discussion during our algorithm session, I have discussed 3 logical orders in writing algorithm. It's the same thing with drawing a flowchart. So we have 3 logical orders, which is sequential, and then we have conditional order, and then we have the iterative order or looping. So all the previously discussed problems are in sequential order, meaning we didn't use any decision symbol yet. So for our next topic, we will be dealing with the conditional order. So under the conditional order, we have what? We have also 3 conditional logic. So the first one is the single alternative. And then we have the double alternative. And then we have the multiple alternative. So again, for learning continuity, we will be using the same problems we have discussed in our algorithm and represent it in a flowchart. So the first type of conditional order is the single alternative, which means we only have one option. So single alternative in programming is the if statement. So since we will be dealing with the if statement, we will now be using the decision symbol or the diamond shape. Okay? So let us discuss this with an example. So write an algorithm that asks for an integer or the variable int, then print higher than 5 if it is greater than 5. Okay? So the only requirement is if the statement is true, you will print higher than 5. So if not, it will just end the flowchart. So single alternative meaning we only have one option. So pag yes, may gagawin. Pag no, it will just end the flowchart. And vice versa. So for our next example, I will be using Microsoft Whiteboard. Na-miss ko lang yung pagsusulat sa board, okay? So, wait. So again, as a review, so this is an example of a single selection conditional order. So again, we will be starting with the terminal symbol and then label it with start, and then right after that, step 2 will be read int or read the number. So an integer is represented by the variable int. So this time we will be using the parallelogram. So we can use the word input or we can use the word read. So read int. And then right after reading the integer, we are now ready to test the value of that integer, whether it's greater than 5. So we only have one selection or one option. That's why it's called the single selection or the if statement in programming. So to do step number 3, we will be using the diamond shape. So the diamond symbol will be labeled as, so the word if, and then this time we will not be using words. We can use relational operators such as less than, greater than, less than or equal to, greater than or equal to, or not equal, and not equal to. So this time, since we will be testing whether if the number is greater than 5. So the integer will be tested. So if int is greater than 5, okay, so what will happen if the statement is true or the condition is true? So don't forget to write the word yes to indicate the logic of the program. So if it's yes, of the flowchart. So if it's yes, so it should print the word higher than 5. So just write here, print higher than 5. Enclosed in double quotation. And then what if the condition is false? So label this branch as no. So there is no option for no. So this will just end the flowchart represented by the terminal symbol. Now we have a hanging branch here or hanging part in the flowchart. So this is a wrong practice. We should end this part also by drawing an arrow here up to this area. So this is our flowchart for this problem. So to explain, so let me have a test data for this. So start and then read any integer. So for example, in this part, I have read 6. So definitely, it should print higher than 5 on the screen since 6 is greater than 5. So 6 will be subjected to this symbol. So int, the value of int or the present value of int is 6. So 6, if 6 is greater than 5, since it's yes, then it will print the phrase higher than 5. So another example, for example, our test data or our test value is 5. We have inputted 5 as the integer to be tested. So let's put this 5. So if 5 is greater than 5, definitely it's no because 5 is equal than 5. And then it will just end the flowchart. So this is the flowchart for our single selection problem or the if statement in programming. Now that we're through with the single selection, let me discuss to you the double selection type of conditional order. So in double selection, we have two options. It's either yes or no. There will be a statement to be executed for both branches. That's why it's called a double selection. You have two options. So let us edit the example that we have for the if statement. By the way, double selection is the if-else statement. Okay? So in programming, it is called the if-else statement. So as an example for that, so write an algorithm that asks for an integer represented by the variable int, then print higher than 5 if it is greater than 5, else print equal or lower than 5. So if it's true, if the statement is true, if the integer is greater than 5, then it will print higher than 5. Else, it will print equal or lower than 5. So we have here the algorithm. So step 1 is start. Step 2 is read the integer. And then after reading the integer, you will test that number if it's greater than 5. So if it's greater than 5, it's going to print the phrase higher than 5. Else, print equal or lower than 5. And then end. So let me start drawing the flowchart. So again, we start with the terminal symbol and label it with start. And then the next step is to read the integer using the symbol, using data symbol or the input and output symbol. So we will be reading the integer represented by the variable int. And then after reading the integer, we will test that integer if it's greater than or lower than 5. So to do this, we will use the decision symbol or the diamond shape. So if int is greater than 5, so if this condition is true, so don't forget to label this part with the word yes to denote the logic of the solution. So if it's yes, you're going to print, of course, the phrase higher than 5, enclosed in double quotation. And then if it's no, or the condition is false, we will be using again the parallelogram or the data symbol to denote that it will print the phrase equal or lower than 5. Okay. And then you have the option if you want to end in this part or in this part. So I'll end this in this part. So drawing the terminal symbol, then end. So for higher than 5, how are you going to end this? So you just draw the flow lines here and then end at this part. So to test the flow chart, so for example, our test data is 4. So automatically, your problem should print, your flowchart should print equal or lower than 5. So let us test. So here in this part, read int, which is 4. So let's test if 4 is greater than 5. So if 4 is greater than 5, so false or no. So it's going to print equal or lower than 5 and then end. What if we input 6? So definitely it will print higher than 5 because 6 is greater than 5. So we input here 6. So if 6 is greater than 5, yes. So it's true. So it will be printing higher than 5 on your display screen or on your display. And then end. So this is the flowchart for double selection. So you have here a statement if the condition is true, and another statement a statement will also be performed if the condition is false. So let me discuss another example for double selection. So write an algorithm that reads the student name, S name, midterm grade MG, and final grade FG of a student. Compute the average. So if to compute the average, is 60% of the final grade and 40% of the midterm grade. Another requirement is to determine whether the student has passed or failed the subject. 75 is the passing grade. Okay, then print the student name, average, and remarks. Remarks will be represented by the word passed and the word failed. So this is the algorithm for this. So step 1 is start. Of course, step 2 is read name. And then step 3 is read MG, FG. Okay, so let me revise this. We can revise this algorithm. So if you want to have a shorter algorithm, you may combine step 2 and 3. So it's just the same process, reading a value for the variables. So read S name, you can write it here. You can write MG here and then FG. And then this will be step 3. So be sure that your variable names are separated by comma. Then after entering or after reading values for MG, FG, and S name, you can now compute the average since you have the value for MG and FG. So step 3 is compute for the average using this formula. Average is equal to MG times 0.40 plus FG times 0.60. Now, after getting the average, so step 4 will be testing whether the student has passed or failed the subject. So if AVE is greater than or equal to 75, since 75 is the passing grade, then it will print student name, average, and then the remarks passed. Else, it will print S name, the student name, the average, or failed if it's 74 and below. And then step 6 is end. So let's draw the corresponding flowchart for this. So again, step 1. Sorry. So let's have the terminal symbol, start. And then the next step is to read S name and MG using the symbol data symbol or the input output symbol. So you have here S name, MG or the midterm grade, and then FG separated by comma. Now after reading this values, we are now ready to compute the average using the midterm grade and the final grade. So to compute or to represent the computation, we will be using the process symbol or the rectangular shape. So AVE is equal to MG times 0.4 plus FG times 0.6. Now that we have the average, we are now ready to test if the student has passed or failed the subject depending on the average that has been computed. So to test, again, we will be using the decision symbol. Since passing grade is 75, so if AVE is greater than or equal to 75. Okay. If the statement is true, so label this with yes. If the statement is true, you will print passed, the student name and the average. So to do this, it will be represented by the parallelogram. So print S name, average, and then the word passed. Now, what if the condition is false or no? So this will print S name, average of the student, and then the word failed. Then the last step is end. Using the terminal symbol. And of course, do not forget this part or the hanging part. So this will also go to the end, to the final step, which is end. So this is the flowchart for this problem. So let us have another example for double selection. Write an algorithm that determines whether a number represented by the variable num is an odd or even number. Print even, the word even, if it's an even number, else print odd. So we have done this in our algorithm session. It has 4 steps actually. So to begin with, step 1 is start. And then step 2, you have to read for a number. And then step 3, test this number if it's divisible by 2. And then if that condition is true, it will print even on the screen. Else, or if the condition is false, it will print odd. Or definitely that's an odd number. Now, when we say even number, by definition, it is divisible by 2. Meaning, if you divide the number by 2, the remainder is 0. Or you can divide it by 2 exactly. Now, in programming, we have another division operator which is percentage. Percentage represents the modulo division. Modulo division. Okay. So, the operator is percentage. For example, 5 modulo 2. So, for example, x is equal to 5 modulo 2. Okay. So, 5 modulo 2 is 1. Okay. So, definitely, 5 is an odd number because you can't divide it exactly by 2. 1 is the remainder. Okay. If the remainder is 1, when you divide it by 2 using the modulo division, so definitely that number is an even number. Okay. So, 5 modulo 2, or 5 divided by 2 is 2. 2 times 2, 4. So, the remainder is 1. So, this is the value that is being returned by the modulo division. The whole number or the remainder part. So, to draw its equivalent flowchart, so let's start with the terminal symbol. So, start. And then we will going to read the number represented by the data symbol. Read num, because it's stated in the program that you have to use the variable num. And then right after that, we're ready to test if the number is an even or an odd number using the decision symbol. So to do this, you have the word if and then num modulo division 2 is equal to 0. So if yes, definitely that is an odd, definitely that is an even, that is an even number. So it will print even. Now, if the condition is false, it will print the word odd. And then the algorithm ends. So again, do not forget this part. Okay. So let me have a test data for this. So for example, read num. For example, 4. Okay. So let's substitute. So if num, if 4 modulo division 2, so 4 modulo division 2, let us find out the remainder. So 2 times 2 is 4. So it has no remainder. So definitely, so the value of this is 0. The computed value is 0. So is 0 equal to 0? Yes. So print even. What if we input 7? Okay, read num, so 7. So let's compute what is 7 modulo 2. So again, may I just remind you, the percentage symbol or the percentage operator is the symbol for modulo division, meaning it returns the remainder value or the whole value of the remainder. So 7 modulo 2. So let's get the computed value or the remainder. So 7 divided by 2 is, So 7 modulo 2 is, 7 divided by 2 is 3. So 3 times 2 is 6. So the remainder is 1. So 7 modulo 2 is equal to 1. Is 1 equal to 0? So no. So print odd. So this is the flowchart for our problem. Now, for the next or the last type of conditional order, we have the multiple selection or the if statement in programming, meaning we have more options or more choices. Okay? So let us have an example. Write an algorithm that asks for a day code or decode and then print the equivalent day. Now, we have here a table. So, days Sunday to Saturday is represented by day codes 1 to 7 respectively. So, if you print 2, it will display Monday on the screen. The same thing with if you press 6, then the equivalent day for that is Friday. And then print invalid code if the user enters a wrong code, or if the user enters numbers or code not within the range of 1 to 7. So here is the algorithm. Now let's draw the equivalent flowchart for this. So we will be starting with the terminal symbol, start. And then step 2 is read decode. So let's use the data symbol or the parallelogram shape labeled by read and then the variable name decode. Now that we have decode, we are now ready to test the code. If it belongs to the range is from 1 to 7. So use the decision symbol for the first condition. So if decode is equal to 1, then it will print. If the condition is true, it will print Monday. Oh no, Sunday. Now, before I enclosed in double quotes or double quotation. Now, before I continue, you may notice that I am using double equal sign. Let me explain this first. In programming, an equal sign and a double equal sign is very much different. This is used for assignment statement. Assignment statement. For example, x is equal to 5, meaning 5 is the value of x. Whereas, double equal sign is a relational operator. Definitely, if it's a relational operator, it returns either a value of, it returns a true or false value or a yes or no value. For example, 5 is equal to 6. So the answer for this is false. So that is the difference between an equal sign and a double equal sign in programming. We will discuss that deeply when we go to C programming. So, but for now, let's continue with our flowchart. Okay. Next is, what if it's not equal to 1? So, another decision symbol will be drawn. So, if decode is equal to 2, so this will be a series of decision symbols. So, print Monday. And then we have if decode is equal to 3. Yes, do not forget the label. Print Tuesday. And then, what if we don't have a space here at the bottom, but then we have spaces here or blank spaces here in our sheets, in our sheet, drawing sheet? We can issue. So I will introduce another symbol for flowcharting, which is the on-page connector. So on-page connector is just a circle labeled either by a number or a letter. So for this, which means that the continuation of this flowchart is within the page or within the same page. So we can use the on-page connector. So let's label this with letter A. So we can draw here. So that only means that the continuation of this will be at this part. And then another symbol. So if decode is equal to 4, it will print Wednesday. You may use the word yes or just the letter Y for yes or no and N for no. But please be consistent. If you use yes at the beginning, then all throughout you use the word yes. So let's change this. So if decode is equal to 5, so that is equivalent to Thursday, print Thursday. And then if decode is equal to 6, print Friday. Now, the last one. If decode is equal to 7, yes, then print Saturday. Okay, what if the user presses a wrong code? So that will be the last statement, okay? So if you have written all the possible choices and the user presses a wrong code, so the last statement will be, or the last false statement will be print invalid code. And then end. Now, we have so many hanging parts here in our flowchart. So, it's impossible or it's not neat to write lines. For example, to denote the ending of this flowchart. Right? So that will be chaotic. So we will use the on-page connector for that. Now, another rule in drawing flowcharts, your flowchart should be neat and clean. So having so many lines, but pardon me with this, I'm using a pen tab. But having so many lines in your flowchart will be a different thing. So we use the on-page connector to denote only one ending. So to do that, so for example, Sunday. So this should end at this point. So we can use an on-page connector. Since we have used letter A, so this is letter B, which means that it will go, or this is the continuation part of this, which is end. So all of these hanging parts will be going to the last step, which is end. So let us have an example. So let us have test data for this. Suppose we have entered the decode 3. So read decode, which is 3. So let us test. If 3 is equal to 1, so is 3 is not equal to 1, so no. So is 3 equal to 2? No. Is 3 equal to 3? So it will print, yes, it will print Tuesday. And then we have encountered an on-page connector. So the continuation of this part will be here. So that will be end. So it has it printed Tuesday. So ang code 3 natin is Tuesday. Okay. So what if we have encode or we have pressed 0? So let us test. Is 0 equal to 1? No. Is 0 equal to 2? No. Is 0 equal to 3? No. So this is the no part. This is an off-page connector. So we will find its equivalent on-page connector. So this is letter A. So the shift of logic will be here. So if 0 is equal to 4, no. If 0 is equal to 5, no. If 0 is equal to 6, no. If 0 is equal to 7, no. So it will print invalid code and then end. So 0 is not included within the range of from 1 to 7. So that will be an invalid code. Now let me discuss another symbol in flowcharting. So I am through with the on-page connector. So let's discuss another. So this is another connector, which is, so we have two connectors, the on-page connector and the off-page connector, just in case we have a long process to draw. So we use these connectors. Okay. So on-page connector means that the shift of logic or the continuation of the process is on the same page. While the off-page connector, the continuation of logic or the continuation of the flowchart is in a different page. So on-page connector is denoted by, again, a circle. It can be labeled with a number or a letter. And then the off-page connector is a pocket-like shape. So it can also be labeled with a number or a letter. So to demonstrate the use of off-page and on-page connector, for example, we have two sheets here of paper, and then you draw your symbols, then you don't have space here at the bottom, so you can use the on-page connector to continue your drawing at this part. And then now, for example, you have exhausted all the spaces in the first sheet or the first paper, and then your flowchart isn't finished yet. So you can use the off-page connector labeled by a number or a letter. So in this case, we use letter A. So that denotes that your flowchart, the continuation of your flowchart is in another page. That's why it's called the off-page connector. So I hope this is clear to you. So the next topic that we will be discussing is the iterative logic or iterative order, or in short, looping.